Okay. Hello, hello. Is there a way to get this to stop moving so much? Whatever. I don't care that much. It's fine. Okay. So. Very exciting. Last night. These are all working. All 4 of these cases. So what if I do like concat arg2? Here, let's try this. I want to see what happens if we have an arg2 and you would never really do this, but if I concat in the EX, so this becomes text, will that then hook up to this because it has the name? That's the question. Out hello world 416. Okay. Then this will fail because we don't have enough arguments. Yep. Okay, that's not a good error message. Couldn't resolve snippet source for call. Decl ref. Right, that's not what it's called anymore. This is do we have the name here? No. This will just be construct node name. Great. Check parameters. Okay. So if I do T here, this will pass TTT. Cool. But text, it should find. Nice. Okay, that works. Great. Just a quick test, see if that worked. Which it does. So, what happens if I just remove the name from this? Can we get back to compiling? How many errors are there? Not a ton. I'll take that. 791 in parser. Parse string concat node. This is the preprocessor, the C preprocessor concat. I think. Maybe. Parse string concat node. In a literal. It's only when we parse strings. Yeah, this is the preprocessor, the C preprocessor concatenation for strings. So, we need to expression decl ref. So the decl ref, decl identifier dot text equals that. Is that good? Is that all we have to do? Yes. 398 in util. This is when we get the param type. Yep. So this is just Param node, let's just construct the node name. Okay. 26 in format string. Okay, now we're getting into the metaprogram. 26. Right, so there's no decl name here. This will be short string name is construct node name of decl ref. So this will just be name. Okay. Metaprogram 62. This will be good to get this out of here. This will be construct node name. Okay, this is what we're gonna do. Short string. Name is wait, this is getting the type name. Hold on. Right. Get type name from node. So this is returning the type as a string, the return type as a string, the base type as a string, the new type as a string. But if it's a decl ref, we want the name. What are we using this for? Oh, this is just in the metaprogram. This is just a metaprogramming thing. Get type name from. Okay. Yes. That's why. You know what? This can be short string. I'm not that bothered by that. Result equals construct node name from node. Otherwise, we can just keep doing what we're doing here. That's fine. That's fine. Get type name from. We're using it as a short string everywhere anyway, so metaprogram 136. Write replace type. Okay, I think this means we can just identifier text, decl identifier dot text 233. Okay, this is actually so this is expanding for loops, for any loops. It's unrolling the loop. And for each decl ref, if we find one that says param, okay, this is fine. This is fine actually. So we'll say construct node name of node. If this node's name is param, then we will just replace it with that. Okay. And then same thing here. We're just replacing the text directly. I don't love this, having to dig in this deep. I need to make an API for this, actually. Anywhere in the metaprogram where we want to modify identifiers, we need an actual API now that that task is more complicated than a short string. For example, instead of node info expert decl ref decl identifier dot text equals we need an easy to use API like update identifier, set identifier, set identifier, node, string, or identifier list. Let's do that. That's fine. Okay, decl name. How many more of these? 3 more. We'll get the name here. That's fine. This can just be name. So all these are going to eventually change. Anytime where we just do name, we're going to have to construct the node name there too. But that will come. We'll do one thing at a time here. Decl name. Do we use that anywhere else? We don't, so I can just say construct node name. And here, this can be construct node name. Great. Now code gen 1133. This is in ref param matches function decl param. We can't follow the decl ref for function calls because they aren't hooked up yet. In fact, that's literally what we're doing right now. So instead, let's search through for function matches by name. Okay, so this is before. We have a function call and we want to make sure that we match the call does not have it hooked up yet. That's literally what we're trying to hook it up right now to the definition. So this can just be function name with return type exists, just takes a short string. That's fine. So let's name, we'll say decl name here. on ref param children 0? No. Ref param. Why children 0? Ref param matches function decl param. We're passing it the call param and the function decl param. So these are two parameters. So why are we grabbing its first child? Ref param, function decl param is a param. These are both parameters. Why are we saying it's a decl ref here? Ref param matches. We only call this in one place, which is right here. Okay. For each child of the function call, if the... Oh, this is not true anymore. Okay, hold on. What is this function? Function call matches decl. Yeah, this is not even true anymore. We're even calling... Oh. Yeah, we are. Wait, so how was that working before? X, Y, N, 2. Right. See, that makes sense that that would fail. Because this is no longer short string call name is construct node name of function call. So this is call name. Our first child is the decl ref. This is no longer true. So we can match there. Okay. So here's the decl ref. The decl name is... Did that fix that? Hold on. Ref param matches. So for each function call, the call param is, right, the child. The decl param is the corresponding child of the decl. If that's not a param, okay, we can skip. If we don't match call param, function decl param. Call param should be Right. Okay. Right. So, call param can be anything. It could be a literal, it could be a decl ref, it could be a function call, it could be a bunch of different things. So, if the ref param is a function call, we need to get the name of it. All right, I had to refamiliarize myself with this. This is just decl name. Right. Okay. If the thing's a decl ref, we pass it the node. Okay, I think we're okay. Yeah. 1320. Yet again. If we're the first child of a function call, we're the decl ref. That's no longer true. God, I need to really make sure that I catch those. Hey, Chandru. Hope things are going well tonight. This is no longer true. That's no longer true. So, if if we're a function call, we want to search for a function that matches our name, which means we can get rid of this. And let's get the decl ref name. Ref name is construct node name decl ref, I think. And then here, if we're a function call, we need to look for functions that have this decl ref name. And then here we can just do decl ref name. I don't know if that's right, but we'll see. 1401. Yep, this is just a short string name is construct node name of decl ref, and this is just decl name. Oops. This is just name. Okay. 4065 and 4081. So these two. This is construct node name of decl ref info. And this is construct node name of decl ref. Oh, not the info. Oh, okay. Yet again, this is not correct. The decl ref info is our expression info, expression decl ref. And this should just be expression. Yes. That needs to go here as well. 4081. If decl is pointing to a function, so if it has a function, this is A. This is A. Okay, we definitely crash, so not great. What if we remove, did I break everything if I remove this function call? Oh. Wait. Yeah, I broke something. Uh-oh. Oh, no, I didn't. B32 is not a thing currently. Let's do int. Okay. So, that works. Let's try calling it now. Now we fail. Okay. Let's see why. That was a lot of changes and some potentially really bad ones. So connect decl refs. Where are, oh god, we're deep down the decl ref tree. AST is nil. It's the Zippo. So this is after we parse and run metaprograms on the whole, for the first time. We connect our decl refs, and when we do that, we are connecting source file. So we go through all its children. Or from the root to the source file to the decl function. And this decl function is main. So we're in main right now. It's compound statement. Its variable, which is, we're looking at X. Okay, so we're looking at X. That's great. The decl variable should have children, which is the function call. It's being assigned to the function call, which is this. That function call is now here. Now we're up here because we're in a function call. So connect decl ref to the function name. Okay. Yep. That's not how that works. Where are we? We are in CodeGen 1484. This is no longer children 0. This is AST info expr function call expression. I'm gonna hit so many things like that, and it's gonna be scary, but it has to happen. Okay. Okay, getting there. Let's see what this spat out. Okay, so that looks good to me. There's test. There's our test function. It didn't forward declare it though, which is why it doesn't know what it is. It should have forward declared that. It did write this out correctly. It called test, but it didn't forward declare test for some reason. Forward declare. Let's look for children 0. Node needs semicolon. If node children 0, okay, we're not doing it there. In keyword function call. Okay, this is not true. This is info expert function call expression children 0. Okay, that's fine. Oops. This is a dot. Okay. Still not setting up the dependency correctly. Where do we do dependency map? Node is independent. Node depends on. Where do I do forward decls? Struct forward decls. Generate source file. Global scope. Why is it just structs here? Enums, bit fields. Generate type dependent source. Okay, node depends on. A function call should depend on the function that it connects to. Right, it was this thing I did down here. I did not think this through enough. So we'll say we're dependent on any function that matches our decl ref by name. Lazy, but it should work as a fuzzy type matching. So decl ref info. What am I using that for? Okay, I'm not even using this. So forget this. On A's type. If A is a function call or a macro call, if B's type is a function, and our expression equals the function name. And then we say we'll depend on it if it's a forward decl. So why do we have a forward decl in the tree? Is forward decl forward Unfortunately, I forget where we do this. Generate a forward decl. Here we go. So for each function in our code, which this is one of them, we add to the type dependent list we add it to the type dependent list here. Well, why the child? Oh, we're switching on the child. Okay, so for each node, if this node is a decl function, we add it to the type dependent list, and we want to generate a forward decl for it. So we push a node on here. We are not setting up the forward decl's identifier here. Didn't we make a function for this last time? Copy node info. Copy node info. Child forward decl. Is that all we have to do? No. So it still didn't do it. Let's, every time we do this, let's just print node nicely the forward decl. And then print node nicely should really do a new line, and I'm really frustrated that it doesn't. There we go. So it did generate one, right? It did. And it did for main, right? Here's main's forward decl right there. Why didn't it for test? So it did create it, and it's putting it on the type dependent list. Type dependent list. Construct type dependent DAG. So the only places this can mess up is the thing I just checked and saw that it is creating one, and then node depends on. Node depends on. So if A is a function call, if it's type node, oh, if it's a constructor, we don't care about that. We'll say expression. If B's type is a function, and if we construct our node name, which is A, let's just do us. How about just us? It should be functionally the same thing, but sorry, one sec. Okay. Does that fix it? That should be functionally the same thing. Yeah. These should be the same thing. But maybe isForwardDecl is getting... What is isForwardDecl checking for? Get all of my children. For each child, if any of them aren't a param... Right, that makes sense. Ignoring parameters, do I have any children? Right? If I do, I'm not a forward decl, otherwise I am. That makes sense. So, a forward decl. Let's see where we're generating this again. You know what? Let's just break there, because I don't really understand what's happening. Generate a forward decl. So let's just do this. This should be, is this main? No, this is test. Okay. So we're generating a forward decl here. Boom, boom. So, let's just skip this and we'll say by the end of this, the forward decl should look like this. Line 69, test with, we'll ignore the identifier for now because we're not doing that yet. Return type int, blah, blah, blah. But it should have no children because there's no body to it. So the forward decl is a function, line 69. Name test, return type int, identifiers nothing, we don't care. And no children. So that looks fine to me. We append that to the list, okay. Now we're doing main, I think. Yes. Okay, so let's go where we generate the forward decls. Generate source file. Here we go. Global defines. Global includes. Struct forward decls. Okay. Enums, bit fields. Okay, let's look at the builder real quick. It's got a line directive. Include. Another line directive. You know what, actually, can we skip past this and get... Yes, let's look at final source. How do I look at this? Copy value. Does this work? Can I do this? Yes. Let's do this. Let's create a macro. Search for /in. Boom, boom, boom. And boom. Okay. So there's main's forward decl. Test just didn't get one, even though it's on the list. We saw it, add it to the list. Let's go to add code gen node. And we'll say this is the first one. Print node nicely to add. Yeah, there we go. We added this global include, test the decl, test the forward decl, main the decl, main the forward decl. We added them. They are there. And we're adding it to the type dependent list. Let's break there on 4292. Let's break here. Let's look. Sorted node. Where is sorted node? Why don't I see sorted node? Did I have to recompile? Did I not recompile? There. Okay. Node is a decl function called main. And is this a forward decl? No. Here's another function. Test. Is a forward decl. Okay. This is a forward decl now. It's a function. Get valid children. It has none. Because this is a forward decl. This one is main again. No, this one does have children. Wait, what? Oh, no. Never mind. Alright, I wasn't paying attention to that. They do have children if they have parameters. Here's the node. Main, but its children are no body. So this is the forward decl for main. Oh, this is a bug in... Wow. Okay, if I give test a parameter, I think this will work. Wow, okay. That's a bug in this. It's not num valid children. Where is this? 3915? This is the wrong call. This is if not is forward decl. So make sure this still works. Wait. Add type dimension code. What was this before? If it has children, then go ahead and do this. Add type dependent codegen node. Okay, what if we just don't do this at all? I don't remember what that check was for. At all. Why were we only adding functions if they had valid children? Because the only ones that wouldn't are parameterless forward decls. I don't know. We're not doing that for any of the other ones, so I don't know. But that's working now, so I'll take that. Okay. Cool. So function calls now work. Decl refs and function calls, we've totally removed decl name from the equation entirely. Which is cool. Right, can we just do all this now? Yes. And if we return a 0 from here, we should see in, which we do. Awesome. Okay, great. Good. You love to see that. Okay. Do meta. Do I already have one for this? Oh. Wait, what is... I don't remember what that is. I think this is done. Okay, so we don't have... I'm gonna make a to-do here for the stuff in the metaprogram right now. There's some stuff in here that should not be part of the metaprogram. Like all this stuff needs to be part of the parser because it's part of the language now. Lots of things in the default metaprogram that should probably be part of the parser / codegen natively, since they kind of define parts of the language. For example, function templates, unrolling loops, etc. What this to do really is saying is we need to take a deep pass across the meta programs and associated source files and figure out where those boundary lines actually are. Okay. So, let's go back to what we were doing. We removed all of the name strings from decl ref and function call. That's awesome. So, let's just go to the top here and just start taking these one by one. If you're a variable, we already got rid of name, actually, from variable. Does that mean... does that mean I can declare a variable from a snippet? Let's see. If I do like int underscore arg concat arg underscore equals 5. And then I do like var test a. Can I now let's do what's a good way to do this? Hello. 1, 2, 3, 4, 5. We'll do 6 there. A plus 1. Right? So this should say create a variable called underscore a underscore and set it equal to 5. And then print out hello, whose length is that plus 1. Can we define a like that? C to do. Okay, we hit an assertion. C to do. Update snippet copy decl refs. If child is a variable. I haven't thought about this yet, but I think we just need to search for construct node name, and if we find it, replace just the text part, because that's all that should exist in this case. Okay, yeah, I think that's true. That makes sense to me. Snippet param for variable. Matching param. Construct node. Dot identifier dot text. The type should also be an identifier, but we'll come back to that later. Does that just work? Yes, it did. So now if I go through here and look at final, that just worked. Great. Cool. Okay. That was simple. They're not all going to be that simple, so that's awesome. So to do identifier also, which it would have to be if I want to be able to let you concat them. Concatenation should be concatable. Parse array params for decl. Is there to do in here? We're creating hidden nodes that aren't in the tree. We still set their parents so they behave like normal nodes, but we don't set their parents' child pointer to match, so you can't query them, nor do they get seen when printing the tree. Yeah. That's definitely true. I don't know if that's not important right now, so I'll just ignore it. Same for those, that's fine. Okay. Function decls. Let's get rid of the name. And let's put this same to do there. Oh, we already do that here. Wait. If I remove this, are you still angry? No. Okay. Let's get rid of that and just replace this to do with this, because we'll come back to it. Oh boy. Now we get to do functions. Let's just get started. parser 1848. Its name. This is when we parse a function decl. Instead of this, we're gonna do parse name. Function decl identifier. Oh. Okay, we have to change how this function works now. So, we don't grab the name up here. We assert token is name. Expect. Do I have an expect name? Expect identifier? Yeah, expect identifier. We're gonna expect an identifier here. Parser. Return type. Context is an AST decl function. And as long as we got one, we can just say decl function identifier is parse name. Parser AST decl function. Let's make sure that that actually compiled. 1848. 1850 identifier type. Yes. So now we don't have an identifier because this can move down to here. If this is a constructor, handle specially, handle as special case. So if peak next token or is it just peak token? It's peak token. Parser's type is an open paren. Then we just, yeah, don't do that. We do the same thing here. We expect an identifier, boom. 1877. Okay, let's just start going through these then. Can we do metagen stuff for return type? Overloads can't differ on return types, so does that make sense? Oh, that's if we want a return type to be type any. I don't think that makes sense because of what this says. Overloads can't differ on return type alone. So if you just wrote a function with an any return type and nothing else is different, yeah, we can't actually do that. So that's fine. We can say, let's just keep going. Here we go. The name. So now we once again expect, let's do the same thing. Get token text. So if construct node name construct node name function decl is operator, then we we need to append onto the identifier append identifier node. We need I want to just append, instead of a token, I want a version of this that just appends an empty one with a string. So let's just make another one, I guess. And this one will just take a short string. Can I consolidate these at all? One takes a token. Yes, this one, okay, this one can come after, and it will just append this. Append identifier node parser list get token text of token context. And then this, instead of get token text, this will just be text. No, that's not true. That's not true. This thing is still going to be here. This, if it's an identifier, so this appends an identifier no matter what it is. Then we switch on let's do this. Text and line number. And then we will say if it's an identifier, we will just we have to do this. Right? So in this case, we're just going to call parser list get token text token line and context. Great. Easy peasy. If it's a concat, if it's a concat, we this is not even correct. This does two things. It creates a new one on the list no matter what. And then here, if it's a token, we do some stuff. So really, let's just copy both of these again. This is one that will take a short string text, U32 line number, do all this, but we don't switch on this. We just do this. Right, there's that. This one does already what it's doing. So the only thing these things really share is this part, which is create append blank identifier node. And that's going to just take the parser, the list we're appending to, and we don't even need the context. In fact, we don't need the context in this one. And then this can just be target equals append blank identifier node, parser list. We'll just assert that we got one. Right? So then all of this can be here. We return target. And then this, once again, goes at the top of this. Okay. We happy with that? So then this can be append identifier node, parser, this thing, identifier, this thing, and what's the line number is function decl line number. $618, what did I do? Right, this is just the text. 676, that's down here. Wait. Oh. Oops. This is not supposed to be there. Okay. Almost. Oh, construct node name. We can't do that in the parser. We don't do that in the parser. Oh, no. It's this thing. It's parse name. Although, why not? Why can't we do that in the parser? What does this rely on? Nothing. This can be in the parser. What are we doing? This can absolutely live in the parser. No damn problem. Wait, what? Get node as string. Can that not be? Oh, this is gross, but you know what? That's fine. I'll just leave it that way. I don't like that. It's gross. I'll leave that for future me to clean up because it is functional. It's just gross. 717. Right, so these no longer have a name. This is... Aha. This is now identifier equals this. Right? And actually, why don't we do this? Let's move these back into CodeGen. Wait, where did that come from? Oh, it was in util. Let's move these back in here. And instead, yeah, instead of doing this, let's just forward declare these, because I want to leave that stuff in code gen, because that's where it makes sense. I don't want to muck up the parser with these, so I will just forward declare them here. Which unfortunately means this has to go with this, which I don't love. Let's move these to the top. Okay, I don't love this. All right, where are we at? Parser 1948. This is parse function decl. Right, okay, we're still doing that. So over here, did I already replace this? No. There. Identifier was not declared. That's right, it's not. So if expect token parse our identifier. Oh, right. So this is just the last thing we parsed, which was the the last token we parse. Which is the last thing in our identifier list. Oh, that's why we had a last parsed. Yes, that's what this was for. Okay, let's not expect token here. Or yeah, we do expect a token here. So why is this even an if? This is not an if. We are expecting a token here. And then we expect a closing one. So what if we just do... This is not actually correct, I don't think. So... So I don't think those are right, but that's fine. 2031. Okay, we're out of that though. That's good. Okay. We grab the identifier on its own now, which we shouldn't. This should be a identifier node. And we will parse name, and this will just be name. And we're in AST decl variable. And we will expect an identifier here. htDecl variable. Might as well assert name. Type is fine. Do we not set the name? I guess not. Why? Why don't we set the name here? We create a function decl. Oh. The variable is a function pointer, and it has a child, which is the function decl. That's the thing that gets the name. That's weird. But that's how it's working. So okay. Parse name cannot convert. Yep, that returns a pointer. Or no, that doesn't return a pointer. No, it doesn't. That's just the whole ass thing. Okay. Okay, where are we now? Oh, okay, that's weird. Now we're failing in main of the whole thing? What? Oh, we're failing in assert somewhere. What? In parser, parse function pointer, there's an assert there that's failing now. If not expression. Oh, assert name. Oopsie. Okay. This is not name, this is identifier. Great. Redefinition of okay, I didn't remove that. Construct identifier string. The parser does not need this at all. We move that back to CodeGen. Okay. Let's keep going. Util 1343. Function decl match. If construct node name of decl function. Function exists. This is construct node name. Wait, no, that's not true. The query, this is a query. That's fine. What are we complaining about? Oh, we have hit the top. Sick. Oh, that wasn't even an error. I jumped the gun on that. 317. This is construct node name. 369. So is this the same thing? Yes, so let's just save this. This will be name. Oh, let's call this node name. This is node name. 298 in CodeGen. When we print it out, this is just construct node name. $8.10. Another children 0. Why are we doing that here? This is a variable. Node match for string. If we are a variable of some kind, if the node, if this variable's a function pointer. Oh, so okay, if it's a function pointer, this is where we have our first child. So this needs to be the construct node name of our first child. Function pointers are variables with a child that is the actual data we care about. That has the actual data we care about. With a first child. Okay. 838. Yes, this is construct node name. $1091. Construct node name. $1251. Construct node name. Okay, all of the work that happened previously to like genericize all of this identifier stuff for function calls and decl refs, because it's made it generic in the system, updating these should hopefully be really straightforward. I hope I don't come to regret saying that, but if these kind of updates are all we have to do, I will feel pretty good. This can just be construct node name. 2588. This is going to be append identifier node. I could have just typed that. Parser size of node info decl function dot identifier. And this is a pointer. And to this, we will do size of and I guess the line number of the thing. I don't actually know if that's right. I think so. We don't have anything else here. And the AS. Wait. Oh, this is okay. This is so you can use size of still. I have to forward declare it, is what this is. So this line number doesn't actually matter. This is not a real thing. Doesn't matter. 3112. Yep. This is not function info. This is construct node name child function. 3217. We get to see how horribly this fails in just a moment. 4058. Great, now this one gets to change. We already did that for A. And in fact, can we not just do this for A? 4074. Yes, we can. Okay. Bro, we are compiling and running after all that. All the work we just did to make function calls and decl refs work. To do that, it required a bunch of plumbing and a bunch of awful stuff. Now to get functions to work the same way, all we had to do was update the functions. And it kind of just works. Well, theoretically, let's actually test this now. So if I have like, let's have it return 5 times x, and we'll do like int testing equals test 10. I don't have a quick way to just write this, which is really frustrating. For now, why don't we just include IOStream? Or no, what is it? What is it without IOStream? It's wow, I can't believe I'm blanking on this. Printf Linux. Holy cow. Standard IO. God. Tells you how long it's been since I've used this. Okay. So now we should be able to just say printf testing. Bro! That just still works? Okay, great. What if we make this a snippet that has an x, and we just have it be 5 times x? Does that work? Probably not. It does! Holy crap! Wow. Dude. Okay, what if we have a snippet int mul return 5. We'll say this is coefficient, and this snippet will call coef coef of 5 times x. Does this still work? Sure does. So what if we pass in arg, and let's just like concat this. So now we have to call this with ff. Dude, functions now support concatenating them. And that's all it took. The last month of getting this working on function calls and decl refs, I just did it for functions in 20 minutes. It supports concatenation and everything. That's fantastic. Holy crap. That is awesome. One other thing to test though. So can we create a function via a snippet? Let's try that. Int arg. Does that work? And we'll concat the or we'll say coef, and we'll concat x there, right? And it will return x. Something tells me that won't work. So we are going to say, let's create a coefficient function for 5. And before we do anything, let's just see if that compiles. Expected expression. Okay, so where are we messing up here? 86. Right here. Wait, in variable? Oh, it doesn't recognize this as a function declaration. It doesn't recognize this as a function declaration. Okay, let's see why. Let's if I can get this part working, I'll probably call it for the night. It's getting late, but holy crap, what a good couple days on this. Where are we? Parse vary. No, we need to be in the parser. Parser. Okay. Parse variable decl. Okay. So if we're here, we expect, where do we expect an expression here? Here? I want to break there. Let's go to where we're parsing a snippet. How about that? Let's go there. Let's go here. Here. Let's go here. This snippet is testing 0. I want this one, test. Okay. So we are inside test. We are parsing this. This is getting seen as a variable decl when it shouldn't. And I don't know why, because this looks the same as like int main. So let's see why that's happening. Peak token. Okay. Next is a fundamental type. If it starts an expression, which it does, what comes after it is an identifier. If the expression starts with a known type, it's likely a function or variable decl. Ooh, okay, I know. That sucks. That's going to become a very big problem once we start concatenating types. That's a bad heuristic to go off of for this. And in fact, okay, well, let's see. So we try to parse a variable or function decl. After next is an identifier. We skip over asterisks and ampersands. It's an identifier. After next is a concat node. After next is a parent open. Oh. And in fact, I have to do a to-do here for this exact thing, where this check is probably going to fail. But also, this isn't right. This after next thing, this isn't even right. We have to update this logic to support concatenation. This logic just doesn't, it doesn't even like expect you to be able to concatenate here. So, and is the parser aware that we're in a snippet right now? Parsing snippet, yes it is. Okay. Okay. Since we already know we don't have for decls, a better way to look for functions is to just scout ahead for a open curly brace. Since we're not going to have for decls, we know that a function is going to have an open curly. I think is where we landed on that. So, yeah. Okay. I think I'm going to call it a night with that, because instead of that's a lot more involved than I thought this part was going to be for right now. So parse function or variable decl. We're going to say down here, we have function decls properly supporting identifiers now. However, this code was not updated to respect that. The above, after, next, and after next stuff should no longer happen because we support concatenation. So we need to handle this the same way we handle function calls / declrefs. Okay. And then, so I'll see this next time. Let's go here. To do, next, we'll say 9/20/2025, next time. Start at the to-dos in parse function or variable decl and continue working until the following snippet works, which is to say we can define new functions from a snippet. Okay, great. Well, that's fantastic. I'm very, very pleased about that. I will definitely be streaming more tomorrow. I'll try to start a little earlier this time, because it gets late real fast when I start this late. So that's great. We have a thing to immediately start on next time, which is here, making it so we can concatenate function names here when defining them in a snippet, and then we can concat and just define a whole bunch of functions kind of like you can with macros. So cool. Well, thanks for watching. Definitely come back tomorrow night if you want to see more progress. Everyone have a good night.